Standard chatbots wait for you to type the next prompt. Autonomous AI agents execute goals on their own, actively using external tools and memory to solve problems in a continuous loop. Today, we are going to build a complete, locally running 4-tier AI agent platform from the ground up using a pre-configured boilerplate. To follow along, make sure your machine has .NET 8, Python, and Angular installed. You will also need a Gemini API key to power the logic. Building an agent orchestration loop from scratch often requires significant trial and error to get the state management right. This boilerplate provides a working, structurally sound foundation in about 5 minutes. An autonomous AI agent relies on 4 pillars. The Python brain stack handles Gemini reasoning and ChromaDB memory. The ASP.NET Core orchestrator manages the execution loop, guardrails, and SQL database state. The Angular frontend gives a real-time window into the agent's perception and action cycles. Splitting the workload across different languages utilizes the strengths of each. We use Python's ecosystem for AI modeling and C# for managing the application state. Step 1 is generating the local SQL database. Open your terminal in the .NET project directory and run the Entity Framework Core migration command. This creates 5 explicit tables: short-term memory, long-term memory, tools, guardrails, and agent state. If the migration fails, check your configuration files. A misconfigured connection string is the most common reason the database won't initialize. These tables allow the orchestrator to pick up a loop exactly where it left off if the application restarts. Without this persistent record, the system would have to start every multi-step task from the beginning after a crash. Next, let's boot up the Python environment. In the Python directory, install the required packages for the Fast API server, the database, and the LLM SDK. Before running the server, open the .env file and paste your Gemini API key into the environment variable. The service will crash on startup if this key is missing. Once the key is in place, the application initializes ChromaDB. This open-source vector store handles semantic knowledge retrieval, acting as the system's long-term memory. Start the Python server and navigate to its localhost port in your browser to confirm the interface is operational. This isolated Python service is now a dedicated reasoning engine. It waits idle until it receives a request for planning or analysis from the orchestrator. Now, execute the C# project. Ensure it boots on an explicitly defined separate port to avoid colliding with the Python service. This illustrates the core ASP.NET while loop. The central API pulls the Python LLM for the next step, verifies the action against safety guardrails, and writes the update to the SQL database. Finally, navigate to the front-end directory. Install the node modules and execute the launch command to start the Angular server. Open the dashboard in your browser. Verify the integration by checking for the 3 green status indicators for the database, orchestrator, and LLM endpoints. These status checks confirm the previously separate layers are now networked into a unified architecture. Let's test the system. In the Angular UI, enter a multi-step goal, such as researching the current weather for 3 cities and summarizing the results. Once submitted, watch the progress tracker. The system moves through the perception, reasoning, tool execution, and memory update phases for each city. The backend terminals reflect this activity. The C# orchestrator logs its handoffs with the Python service as the task executes. Now that the loop is operational, you can begin expanding its capabilities by adding your own custom tools directly into the C# SQL database. By isolating the logic, orchestration, and interface into distinct layers, this boilerplate provides a modular structure. You now have a working template to build and test more sophisticated autonomous workflows on your local machine.